This is the P&ID for the LNG Liquefaction Plant. The purpose of the liquefaction unit is to produce liquefied natural gas, or LNG, product from a pre-treated natural gas feed stream. On this P&ID, the blue lines represent the natural gas stream, the green lines represent the propane stream, the red lines here represent the mixed refrigerant, or MR, stream, and once it reaches the MR separator, this red line here represents liquid MR, and this orange line represents vapor MR. This version of the simulator is the metric units version, and we are currently working on developing an English units version. This simulator is also paired with a 3D virtual reality outside operator, which is two-way communicable with the DCS, meaning any changes made on the DCS can be seen in the outside operator and vice versa. This first screen here shows the natural gas path. Dehydrated feed gas is supplied and cooled by 4 pressure levels of propane in E101 through E104 at successively lower pressures and temperatures. The pre-cooled feed gas is liquefied and subcooled in the Main Cryogenic Heat Exchanger. After the LNG leaves the Main Cryogenic Heat Exchanger, it is expanded in turbine T102 and sent into the flash drum V110 and pumped into storage tanks using P101. This next screen shows the mixed refrigerant system. The mixed refrigerant, or MR, used to liquefy the natural gas is a mixture of nitrogen, methane, ethane, and propane. Low-pressure MR vapor comes in from the warm end of the Main Cryogenic Heat Exchanger and is sent through a low-pressure, medium-pressure, and high-pressure compressor and aftercooler to be compressed and cooled by ambient air. High-pressure MR from the high-pressure aftercooler E115 is cooled and partially condensed as it passes through the propane kettles here. This screen shows the propane cycle. The propane refrigeration system uses propane evaporating at 4 pressure levels to supply refrigeration to the feed circuit and the MR circuit. Propane from the discharge of the 4-stage propane compressor C104 is desuperheated and condensed by ambient air in the propane desuperheater E111 and the propane condenser E112. The condensed propane is collected in the propane accumulator V109, which is sent through the propane subcooler E113 before being supplied to the evaporators for the refrigeration of MR and feed gas. The propane vapor generated on each level of propane are returned to the propane compressor via suction drums V105 through V108. These suction drums are separated by low pressure, medium pressure, and high pressure. This last screen shows the Main Cryogenic Heat Exchanger. The Main Cryogenic Heat Exchanger has 2 bundles, a warm bundle and a cold bundle. And in the heat exchanger, the liquid and vapor MR works to cool and condense the natural gas into liquefied natural gas. The MR from the propane kettles is phase separated into the MR separator V101 right here into vapor and liquid streams. Again, the vapor is represented by the orange stream and the liquid is represented by the red stream. Vapor from the separator is condensed and subcooled in the Main Cryogenic Heat Exchanger as it passes through the warm and cold bundles. The vapor exits at the cold end and its pressure is dropped across a JT valve, FCV 103. The low pressure re-enters the Main Cryogenic Heat Exchanger to provide cold end refrigeration. The liquid from the separator is subcooled in the warm bundle of the Main Cryogenic Heat Exchanger here. The liquid leaves the cold end of the warm bundle and is reduced in pressure across a turbine T101 or a JT valve in case the turbine is unavailable here, FCV 105. The low-pressure liquid re-enters the cold end of the warm bundle to provide refrigeration as it vaporizes. The low-pressure MR is totally vaporized and superheated as it leaves the warm bundle of the Main Cryogenic Heat Exchanger to go into low-pressure MR suction drum V102 and the compressors and aftercoolers to be compressed and cooled again out this stream right here. Now we will look at the outside operator. So this is the outside operator for this LNG liquefaction plant. Looking at the legend here, we can see that the Main Cryogenic Heat Exchanger is here. The MR separator is right here. The chillers are seen around the middle right here. The air coolers are what this structure is made out of. And the propane accumulator is here and the LNG product pump is here. And from the back view, we have the turbines back here and the suction drums for the MR and the propane. Here are the mixed refrigerant and natural gas chillers. If we go to the right, we can see the Main Cryogenic Heat Exchanger. This is the Main Cryogenic Heat Exchanger. And this tank right here is the mixed refrigerant separator. If we go up these stairs here, we can find the MR compressors and the propane compressor. These two compressors right here are the low pressure and medium pressure mixed refrigerant compressors, C101 and C102. And these two compressors are the high pressure mixed refrigerant compressor and the propane compressor, C103 and C104. If we go down these stairs and around to the back of the plant, we will be able to see the suction drums. To my left right here, you can see the two mixed refrigerant suction drums, and to my right, you can see the 4 propane suction drums. Here's where you can operate the LNG product pump. And start it and stop it, pressing these 2 buttons. This big white tank right here is a propane accumulator, and as you can see, this structure on top is completely made of fans for cooling. I'm now going to show you what will happen if T101, this turbine right here, is turned off. We would expect the JT valve FCV105 to open up and for the exit temperature of the LNG product to slightly increase from -159.33 degrees Celsius. So I'm going to turn off the turbine and the DCS operator right here. And in the outside operator, look here, this light is gray, indicating off. If we go back to the DCS screen, we can now see that FCV 105 has opened up. We will now look at FCV 105 in the outside operator. So here's FCV 105. If we open it up, we can see that the output is greater than 0, indicating that it's opening. And if we go back into DCS, we can see that TI 121 is starting to rise from -159.33 degrees Celsius since the turbine has been shut off. Thank you for watching.